Hello, my name is Cedar Birdsall, and I'm going to be giving an informative speech about plate tectonics. Imagine Earth is a giant cracked eggshell, with each piece or tectonic plate shifting over a boiling pot of water. The movement of these shell pieces or tectonic plates is what shapes our world. Tectonic plates are the driving force behind many geological features and natural events. I looked at countless sources and am in a class learning about plate tectonics right now. In this speech, I'm going to talk about how plate tectonics work, the different types of plate boundaries, and how the movement of these plates directly affects us. But to understand, we got to start with the basics. Understanding Earth's layers and how plate tectonics work. Ask yourself, how many of Earth's layers can you name? Tectonic plates are located in the lithosphere, which is made up of the crust and mantle. The lithosphere sits on top of the asthenosphere, and the lithosphere is solid, while the asthenosphere is made up of kind of like ductile, Play-Doh-like substance, or not substance, material. George Jester states that there are 7 major plates and 8 minor plates. You're probably wondering, how do these plates move? Well, these plates are driven by convection in the asthenosphere. Heat from the core radiates up in the asthenosphere, heating up that ductile material, which causes it to rise, and then as it gets away from the heat source, it cools, coming back down, creating convection, and it's basically the engine which causes these tectonic plates to move. Earth's layers allow the movement of tectonic plates. To better understand plate tectonics, we need to look at how they interact with one another. How many of you have wondered how the Himalayas were formed? Plate tectonics, or plate boundaries, are on the edge of tectonic plates. There are 3 different types: divergent, convergent, and transform. Divergent plate boundaries are when 2 plates are pulling away from each other, and the result of this is you get mid-ocean ridges. An example of a mid-ocean ridge is the Mid-Atlantic Ridge. NOAA states that the Atlantic Ocean widens 2 to 5 centimeters a year from the North American plate and Eurasian plate pulling away from each other. Convergent plate boundaries is when 2 plates are moving towards each other. If it's oceanic and continental crust moving towards each other, the denser crust will subduct underneath the other plate. So oceanic is a lot more dense compared to continental crust. So when they collide, the oceanic crust is going to go underneath the other plate and subduct. And you'll get a subduction zone. When continental and continental crust collide, though, you get mountain building. And to answer that question at the beginning, that's how the Himalayas were formed. You got 2 continental crusts colliding with each other at a convergent plate boundary, and that leads to the crust crumpling, widening, and you get mountain building. Lastly, we have transform plate boundaries, and these don't pull away or go towards each other, they rather slide across, more of a shearing motion. Each type of plate boundary is different and leaves behind recognizable structures on our crust. What are the effects of all this movement? Show of hands. Who has experienced an earthquake? The movement of these plates directly affect us. Earthquakes are caused from the brittle plates getting caught on one another and the pressure building up, and once that pressure is released, you have an earthquake. In the 1960s, a magnitude 9.5 rocked southern Chile. The USGS stated that 1,600 people died and there was $550 million in damages. It happened in result from the Nazca plate subducting underneath the South American plate, which is a continental crust, and the Nazca plate is oceanic. Volcanoes are another result of tectonic movement, are commonly found as subduction zones. The subducting plates heats up as it reaches deeper in the asthenosphere, and this dehydrates the rock and the rock releases water or volatiles, which then lower the melting point of the material above it, allowing magma to melt that rock and then eventually reach the surface and erupt, forming volcanoes. Lastly, continental drift. Plate tectonics are responsible for Earth's geography we have today. We used to be part of a supercontinent called Pangaea. 200 million, according to the USGS, states that Pangaea broke up 200 million years ago. The movements of these plates caused continents to drift and separate into where they are today. Let's bring this all together. Understanding plate tectonics is essential for understanding Earth's processes. Driven by convection cells in the asthenosphere, the gradual movement of tectonic plates impacts Earth's geographical features in our lives. Plate tectonics shape the world around us and affect our lives. Plate tectonics give this rock in space we call Earth personality. It builds and brings it to life, building and destroying in its ongoing tectonic dance.